Hi, I'm Tom Biebighauser with Wetland Restoration and Training. I'm standing on the dam for a constructed fishing pond, and this dam was built over 40 years ago. Isn't it beautiful? Well, did you realize that almost every pond, every ranch pond, every wetland across North America has been built using a dam? And guess what? They all require maintenance. I've built over 1,400 dams in my career, and I've yet to figure out how to build a dam that you don't have to regularly inspect and maintain. Well, in this video, I'd like to show you how to inspect and how to maintain dams that have been constructed for ponds and wetlands. Let's get started. Dams are built across streams to create large pools of water. The red dashed line shows the location of a dam that was built across an ephemeral stream to create a farm pond. A dam may also be called a berm, a dike, an embankment, a levee, or a weir. You're looking at a dam that was built across a narrow place in a valley so it would back up a pool of water. The dam was built over 50 years ago. The clay soil used to build the dam was dug out of the hillside on one side of the valley. In some cases, the soil needed to build the dam is dug out of the area that will be flooded by the dam. This drawing shows a dam that was built across a stream to create a large pool of water. Here is a typical farm pond that was built in the 1970s with technical and financial assistance from the Natural Resources Conservation Service. The pond is in a valley with a large watershed. A high dam was built with steep slopes. A fence was erected to keep livestock out of the water. A spillway is usually constructed for each dam that's built. The spillway provides a way for water to flow around the dam and not cause erosion. A water control structure and a drain pipe are often installed when dams are built. The water control structure provides the primary way for water to flow past the dam without causing erosion. When there is a flood, the stream will flow both through the water control structure and the spillway. This drawing shows the main parts of a constructed wetland or pond that should be inspected to see if they require maintenance. You should examine the dam, the spillway, the drain pipe, and the water control structure if one is present. It's important to mow the dam so you can inspect it for damage. I'm using a small 26 horsepower tractor with a 5-foot wide bush hog to mow the dam on a wetland I built in our farm over 20 years ago. The 4-wheel drive tractor will help keep me from getting stuck in the mud or slipping on wet and steep slopes. I must be careful not to get too close to the water's edge, or I could get stuck in the mud or go swimming in the wetland. Because I don't have a batwing mower, I need to back up to mow the trees and the shrubs that are growing on steep slopes and that are growing along the water's edge and that are growing in the spillway. It's important to mow the dam and the spillway twice a year to control trees and shrubs that are growing on the dam. It's important to use a string trimmer to cut trees and shrubs that are growing on the dam and in the spillway that you can't mow with the tractor. On dams with steep slopes that can't be mowed with the tractor, it will be necessary to use a string trimmer to clear the entire surface of the dam. So when you're trimming the shrubs around the wetland that you're maintaining, please don't cut all these valuable aquatic plants. There's no reason to do that. What I see here are sedges and rushes and all these different flowering plants like boneset. This is what we want around the wetland's edge. So please don't trim them. There's no need to. Let's inspect the dam that was constructed for this wetland. I'm going to start by looking at the water level in the wetland. It's to capacity, no sign of the water level going down. Good assortment of aquatic plants. I'm going to start by walking the peak of the dam or the crest of the dam and going slowly and looking for any burrows that have been made by muskrats or canals that have been made by beaver. I don't see any holes, but I see a great diversity of plants that are growing along the inside slope of the dam. And again, it looks like the water level's to capacity. There's no settling, there's no holes. I get in position so I could really see that water's edge because that's where the muskrat burrows would be easiest to detect. There's a few little ruts in the dam from when I mowed it when it was wet. And here I see a poplar tree that will need to be cut. And now I can see the overflow pipe, which we'll look at closely. And it looks like it's functioning as planned. Looks like here's where muskrats have been at one time, but there's no burrow. You're looking at the overflow pipe on the water control structure. It's a vertical pipe. and it connects to a drain pipe and it carries water underneath the dam without causing damage to the dam. It looks like it's functioning properly. However, the aquatic plant water shield is partially blocking the entrance to the pipe, and it will only get worse. It could block the entrance to the pipe, so we better clean that out so the pipe works as planned. Now I'm going to inspect the back slope or the back side of the dam, and again, look for any burrows, any leaks. Here's part that I didn't mow because it was too wet. It's a wet meadow wetland. The slope looks good. It's nice and gradual. I don't see any seeps. I don't see any burrows. No trees growing on it. Here's some ruts along the lower edge of the dam. That's where water's been collecting next to the neighbor's road. Now I'm coming up on the outlet for the drain pipe. I have it rocked so there's no erosion. There is water flowing in it. No seeping. Here's the entrance to the spillway that carries water around the dam without causing erosion. It's located at one end of the dam, and it's wide, and it looks like it has a gradual slope, and it's full of these aquatic plants. It's a wet meadow. It's really important to inspect the spillway, and to do this, you should walk along the spillway and look for any erosional gullies, look for any head cuts, look for any problems. Maybe something's blocked the spillway. But what I see here is this wide wet meadow, at least 14 foot wide. The water's in a sheet-like pattern, and it looks like the water is just seeping out of the wetland and not causing erosion. But as I come over here, there are some ruts that I just caused when I mowed the dam. I was going through the spillway, and because the soil was saturated, I left some ruts behind, but they are perpendicular to the flow, so they're not causing any problems. And again, I'm walking the length of the spillway now. The water is still spreading out and not causing any erosion. I'm going to continue walking the spillway. I'm following the flow. I have rubber boots on because the ground is wet. And right here, the water starts spreading out and forms this large wet meadow. And I'm going to keep going until the spillway leaves my property and see if there are any head cuts where the spillway drops into a ditch. So I'm going to keep walking the spillway, keep walking it. A wonderful diversity of plants. And here the water spreads out, seeps underneath the road. There are no head cuts. It's in good condition. It's very difficult, if not impossible, to inspect a dam that has not been mowed. The trees and shrubs you see growing here, they're growing on a dam that has not been mowed for many years. The dense growth of trees and shrubs makes it almost impossible to find holes, breaches, or seeps in the dam. This dam can no longer be mowed with a tractor and a bush hog because the trees are too large a diameter to ride over with the tractor. This is a muskrat. They live in wetlands and ponds. The muskrat will burrow into a dam underwater and create a living cavity in the dam that is above the water level in the pond. Sometimes muskrats dig through a dam. When this happens, the water level in the wetland will go down, and in some cases, the dam will wash out. The red dashed line shows where a muskrat burrow enters the inside slope of a dam. The muddy water shows that muskrats are swimming in and out of the burrow. Here's where another muskrat burrow enters a dam. This muskrat burrow is draining a wetland constructed with a dam. The water level in the wetland is being controlled by the elevation of the muskrat burrow in the dam. You can test to see if a muskrat burrow is draining a wetland by using your feet to muddy the water at the entrance to the burrow. Watch to see if sediment in the water is flowing into the dam. The water is circling at the entrance of this burrow, so it's not draining the wetland at this time. To prevent the dam from failing, it is very important to use an excavator to expose each muskrat burrow and then to fill each burrow with clay that is compacted. Here's a muskrat hole in a dam as we began to dig it out. Dams that have water on each side, like this one, are often riddled with muskrat burrows that enter from either side. At first glance, it looks like this water control structure is responsible for the almost dry wetland. Upon closer examination, I found where a muskrat had dug a burrow through the dam along the drain pipe. Water was flowing through this hole in the dam. Here's the outlet of a drain pipe on the backside of a dam. Mud is flowing out of the hole in the dam that was dug along the outer edge of the drain pipe and not from inside of the pipe. Beaver often move into constructed wetlands and ponds and can be expected to quickly modify the dam, spillway, and the water control structure. Here is where beaver have dug a channel through the dam of a constructed wetland. The channel is draining the wetland just like somebody dug a ditch through the dam. Here's another channel that beaver dug through the top of a dam. We use a boot to stir up the mud in the channel to see if water is flowing out of the wetland. The muddy water appears to be swirling in circles, which means that the channel is not draining the wetland. There does not seem to be an urgent need to fill the beaver channel at this time. This wetland was built without a spillway. Water flowing over the dam created a head cut that cut through the dam and drained the entire wetland. This photo shows where a beaver built a channel down the center of a spillway that had been constructed for the wetland. The deep and narrow channel is lowering the elevation of water in the wetland by 18 inches. Here is where beaver built a dam across the entrance to a spillway for a large constructed wetland. Beaver built the dam across the spillway after they had blocked the overflow pipe and the water control structure in the same wetland. Here, beaver built a dam that is made from mud and sticks on top of the dam that had been constructed for the wetland. The beaver are trying to block places where water is flowing over the dam after they had blocked the water control structure and the spillway. The higher water level created by the beaver was backing up water in a culvert under the township road that was adjacent to the wetland. Road maintenance personnel expressed concern that the high water level in the wetland was affecting the road. I decided to remove the beaver dam blocking the entrance to the spillway by using a rake. This was because I was not able to lower water levels by adjusting the water control structure, and I could not find the overflow pipe that had been buried and blocked by beaver. I was concerned about asking the township to remove the beaver dam with heavy equipment. This is because they could also dig a ditch that would drain the wetland. My concern was based on the short section of ditch and the pile of soil that you can see next to the willow tree. And this is where someone earlier had used heavy equipment to remove the beaver dam. Water is now flowing in the spillway and downstream where it will enter another wetland that we built. It is very possible that beaver will rebuild their dam in a couple of days, so there will be a need to regularly visit the site to remove the dam. The long-term solution would be to change the spillway into a permeable rock drain. To do this, we would need to remove the beaver dam using an excavator and then fill the spillway with a thick layer of rock the size of footballs. Water could flow out of the wetland in between the spaces between the rocks where it would be more difficult for a beaver to detect and to block. Here's where beaver dug a channel through a dam and the channel drained the wetland. Beaver then tried to block their channel by building a dam across it without success. This beautiful pond was built over 50 years ago on land that is now owned by Dr. Gabriel Levine in the Coastal Mountain Range of Northern California. Not only is the pond attractive, but it provides habitat for a diversity of native aquatic plants and animals. The pond is being used by the rare foothill yellow-legged frog for breeding. The red-bellied newt, which is a salamander, is also breeding in the pond. The red-bellied newt is found in coastal wetlands, especially in redwood forests. They can live up to 20 to 30 years. Their bright color on their underside warns possible predators that they're poisonous to eat. The pond on Gabriel's land was constructed over 50 years ago by building a high dam across the stream. The dam was built using clay texture soil that was obtained on site. The dam was built with slopes that were too steep to mow with a tractor. Large redwood trees and Douglas fir trees are growing on the sides of the dam. The roots of these trees are undoubtedly removing large quantities of water from the wetland. When Gabrielle acquired the property, she and her partner Dan observed that the spillway for the pond was eroding. A pipe that was too small in diameter had been used to carry water over the dam. Water flowing out of the pipe had washed a chunk of soil out of the dam. During a flood, water would flow around the pipe, causing a head cut to form in the backside of the dam. Gabriel and Dan wanted to take action to rebuild the spillway before the dam washed away. Dan used their excavator to shape a soil ramp so he could access the spillway. He then placed logs to form a temporary bridge over a deep hole that had washed out. One of the first steps he took was to lengthen the overflow pipe so it would connect with the existing culvert under the road. The red arrow points to concrete that had been used to line a portion of the original spillway. Water was flowing under the concrete and causing erosion. The yellow arrow points to large boulders that Dan placed at the base of the spillway to control erosion. You're looking at the rebuilt spillway that's no longer eroding. Large boulders were embedded into the ground at the base of the spillway to control the head cut. The overflow pipe was extended so there would be no erosion taking place at the outlet end of the culvert. The spillway was made wider and then armored with angular rock to control erosion. The galvanized steel overflow pipe will carry the normal flow over the dam without causing erosion. A pipe over 6 feet in diameter would have been needed to transport all the water during a flood. This would have been very expensive to purchase and to install. The rock-armored spillway will carry flood water over the dam without causing erosion. Dan used fractured angular rock that was mixed in size from 6 to 12 inches in diameter to armor the spillway. Because this rock fit tightly together, it was less likely to move during a flood compared to using rounded river rock. The project took 4 weeks to complete. Here's how the maintained pond appears in the spring. The pond is growing a diversity of native plants. We agree there was no reason to cut the trees that were growing on the dam. The repairs they completed on the spillway should protect the dam and the animals using the pond for many years. The red arrows mark where 2 major head cuts are advancing up the spillway towards the dam, causing great erosion and the eventual failure of the wetland. Livestock access to the spillway is causing a great deal of erosion. The pond you see in this aerial photo was constructed to clean runoff from a coal mine in Russell County, Virginia. The red dashed polygon shows where a dam was constructed across a stream to build the pond. The yellow dashed polygon shows where a concrete-lined spillway was constructed to carry water over the dam and not cause erosion. Here's the stream flowing over the concrete-lined spillway. There's no erosion, so everything looks okay. However, one can see a major head cut at the base of the concrete spillway where the concrete is broken off and soil is being washed from under the concrete. The dam will fail if water washes a channel beneath the concrete. Here's another major problem with the spillway. Beaver have built a dam across the entrance of the concrete spillway. It's now possible that water will flow over the dam and wash out the dam during a flood. An excavator should be used to remove the beaver dam. At the same time, the beaver should be trapped and removed to prevent the dam from failing. We built this small wetland on land owned by Morehead State University in eastern Kentucky. The red dashed arrow marks the location and the path of the spillway that we built for the wetland. The spillway was designed to carry overflow from the wetland away from the adjacent hiking trail. Someone blocked the entrance to the spillway with branches. Water is now flowing out of the wetland and down the trail instead of in the spillway. People often block spillways, possibly thinking that they're repairing a leak in the pond. Livestock can cause damage to dams and spillways. The small tree is growing in a dry, constructed pond. Livestock destroyed the spillway and the dam by trampling trails that became ditches that drained the pond. Unmanaged livestock access to this pond has sheared the face of the dam and lowered the elevation of the spillway that's resulted in draining the pond. Many ponds and wetlands like this one are built without a spillway. Instead, a pipe or a culvert is used to carry water through the dam and not cause erosion. An overflow pipe that carries water through the dam can be difficult to find. The entrance to an overflow pipe must be kept clean of debris. If the entrance of the pipe becomes blocked, water can flow over the dam and wash out the dam during a flood. A major problem with using an overflow pipe instead of a spillway is that most people install a pipe that is too small in diameter to handle flow during a flood. Large diameter pipes are expensive to purchase, so landowners often think that the pond will last with a smaller diameter pipe. It's of great importance that the entrance to the overflow pipe be cleaned of debris every week to make sure that it stays open. This small pond was built in eastern Kentucky about 40 years ago. The pond has held water at or near capacity since it was constructed. The dam is about 8 feet high and blocks a small stream. The dam was built with a flat top about 10 feet wide with steep slopes on either side. The many trees and shrubs with thorns that were growing on the dam made it challenging to inspect the dam for holes and leaks. Fortunately, I did not find any muskrat or beaver burrows in the dam. The dam was built without a spillway. I found these 6-inch diameter pipes with water flowing under them on top of the dam. The stream was flowing under the pipes and was carving a ditch through the top of the dam. Walking to the back side of the dam, I could see where each overflow pipe was turned downward using 45-degree elbows. No water was flowing in the pipes. It looked like the pipes had been installed where a spillway had been made with rock at one time. The original spillway was armored with rock, much like a waterfall, and did not involve the use of pipes. The water flowing over the dam had formed a 4-foot-high head cut in the spillway. I suspect that someone had installed the 2 overflow pipes because they did not want to rebuild the rock spillway. I recommended replacing the 2 smaller diameter pipes with 3 sections of 12-inch diameter double-wall plastic pipes that would be joined together with gasketed fittings. A large amount of soil that is high in clay would be needed to cover the pipe and to fill the section of the dam that had washed out from water that was flowing over the dam. I located an open area on high ground near the dam where the clay soil needed to repair the dam could be obtained. The soil test hole I dug with an auger in the open area showed that there was clay approximately 10 inches below the surface in a layer about 3 feet thick. There would be a large enough quantity of soil to repair the dam. However, the landowner would need to harvest the clay with an excavator and then move the clay downhill to the dam using a skid steer. I recommended reshaping the borrow pit into a vernal pond once the landowner was completed with the project. Wayne Black's grandfather built this beautiful farm pond over 50 years ago in eastern Kentucky. He uses a tractor and a batwing mower to cut the plants growing along the water's edge. This is so he doesn't get stuck in the mud. The dam for the pond was built across a valley. It has a wide top and gradual slopes so it could be mowed using a tractor. The pond does not have a spillway. Wayne uses a pitchfork to remove vegetation that could block the entrance to the overflow pipe. This pipe carries water through the dam. It's surprising how only a few plants can block water from entering the pipe. Here he's removing the grass that collected in front of the pipe after he cut and baled the hay that was surrounding the pond. You can see where his batwing mower damaged the inlet to the plastic overflow pipe. The water you see is standing in the ruts left by the tractor that was driving through saturated soil downhill of the overflow pipe. I follow the flow of water from the pipe downhill where I find 2 head cuts. The head cuts are moving uphill and will eventually drain the pond unless they're controlled. The white plastic pipe leads from the pond to a livestock watering trough. Boards were placed over the eroding stream channel just like a bridge. The boards are doing nothing to stop the head cuts from advancing. Additional head cuts are in the stream downhill of the fence. This beautiful pond is located near the Ledford House restaurant in Albion, California. A path has been mowed across the top of the dam. It was not possible to inspect the dam because of the dense vegetation that was growing on the slopes of the dam. This culvert is the overflow pipe for the pond. The concrete in front of the pipe is a water control structure where boards may be inserted to raise the water level in the pond. An irrigation pipe was installed in front of the structure and in front of the culvert. Both the water control structure and the irrigation pipe are reducing the capacity of the culvert to carry water during a flood, and this could cause the water to flow over the dam. The soil covering this overflow pipe could wash out in the next flood unless livestock are kept off the dam and the spillway is constructed to handle overflow from the pond. DJ Bushman, a private landowner in eastern Kentucky, contacted me because he was concerned that beavers were damaging a dam that had been constructed by a previous landowner on his property. The dam had been built across a narrow valley with steep slopes to create a 1/2-acre pond. The dam had a narrow top with steep side slopes. No spillway had been built to carry water around the dam. Drift on the dam showed that water had flowed over the dam during a recent storm. I observed a 24-inch diameter plastic overflow pipe whose entrance had been blocked halfway by beaver. I could not believe that beavers were living in this small pond that's located in the mountains and in the forest. DJ showed me where 2 additional overflow pipes had been installed in the dam. I would not have been able to find these pipes without his help. The entrance to one of these pipes was completely buried and blocked by beaver, while the entrance to the other pipe had been dug out, possibly by a beaver using it as a bank den. I used a shovel to remove the soil and plants that were partially blocking the entrance to the large diameter buried pipe and the larger diameter pipe. The beaver had built a low dam using mud and water shield that was found growing in the pond. I then used the tile probe to find the exact location of the entrance to the overflow pipe that was completely blocked by beaver. Using a shovel, I removed the beaver dam that was completely blocking the entrance to the smaller diameter overflow pipe. It's very important to keep these pipes open, as one heavy rain can cause enough water to flow over the dam and wash out the dam. I recommended filling the entrance to the third and the shortest section of pipe that was buried in the dam. I wanted to fill this with soil to prevent water from flowing through or around it. I was concerned that water flowing in the old pipe could wash out the dam because it was short and rusted. Wes Maddox, wildlife biologist for the Kentucky Department of Fish and Wildlife Resources, has had success preventing beavers from completely blocking overflow pipes by installing corrugated, flexible, slotted plastic drain pipes in the pond and in the dam. The drain pipe was installed so it passes through the inside of the existing drain pipe and then empties water beyond the outside base of the dam. The inlet to the slotted drain pipe is placed on the bottom of the pond at least 50 feet from the inside toe of the dam. The slotted pipe is anchored to the bottom of the pond so it does not float. The drain pipe inlet is blocked with a cap to keep beaver from plugging it. I recommend using the largest diameter slotted drain pipe you can find that will fit through the existing drain pipe, and this is normally 6 inches in diameter. The slotted drain pipes are generally sold in 100-foot-long rolls. The dam for this wetland is not holding water. The main reasons are that the water control structure was left open and there are muskrat holes that go through the dam. Here's the water control structure that was left open. This is called an inline water control structure that's made by AgriDrain Corporation. It serves as both a water control structure and as a drain. The AgriDrain inline water control structure contains plates with gaskets that can be added or removed to adjust water levels or to drain the wetland. Here's a typical installation for an inline water control structure. They're usually placed in the center of the dam. The cover can be removed from the inline water control structure so the plates inside can be added or removed. A specialized tool is used to remove or to add plates for adjusting the water levels. The gaskets and the plates are prone to tearing, breaking, and compressing. This can cause the water control structure to leak and the wetland to drain. This inline water control structure was destroyed by a tractor that was mowing the dam. This is a common occurrence as it is very hard for the operator to see the water control structure when tall vegetation is growing on the dam. Replacing an inline water control structure that's damaged is a big job, and it involves draining the wetland and using an excavator to install a new water control structure and a new drain pipe, and this is all done at considerable expense. This water control structure is called a flashboard riser. Water levels are adjusted by adding or removing boards in the channels that are on either side of a large diameter pipe that's been cut in half. This video shows how a flashboard riser is supposed to work. The level of water in the lake is controlled by the number and the height of the boards that are placed in the structure. Water rises in the lake until it flows over the top board and then under the dam through a large diameter culvert. All flashboard risers leak. When installed in a wetland or a pond that's not supplied with water from a perennial stream, the pond will often dry because of water leaking between and around the boards. Dry wetlands and ponds are common where flashboard risers have been used because they all leak. Here's where beaver filled and covered a flashboard riser with mud, sticks, and vegetation. However, they were unsuccessful in blocking water from flowing through the structure because of how badly it was leaking. This is one of many water control structures I've seen that's been damaged by ice. The high and narrow dam was also breached by muskrat and by beaver burrows. It wouldn't be safe to walk on this catwalk to open or close the valve on the water control structure because there's a danger of falling through the rotted boards. This drop tube water control structure broke free of the aluminum post that held it in position. Longer PVC pipes could float unless they are firmly attached to stakes driven into the ground. This drop tube water control structure is working as designed to control the water level in the wetland. Unfortunately, beaver often block these structures by covering them with huge mounds of soil and vegetation. Here's a simple and inexpensive water control structure that's combined with an overflow pipe that's been working for 27 years with absolutely no maintenance. The water control structure is located on the backside of the dam, and it's not in the wetland pool. We use sections of 8-inch diameter PVC Schedule 35 SDR gasketed pipes for the drain pipe, which was installed under the dam during the construction of the wetland. At the outlet end of the drain pipe, we attached a 90-degree SDR 35 gasketed elbow and inserted a short section of pipe into the fitting. A laser level was used to set the elevation of the top of the vertical pipe so that it would be equal to the maximum water level that we wanted in the wetland. This upright pipe was attached to aluminum stake using plastic lock straps that later broke. The vertical pipe should be secured to the stake that's driven into the ground using galvanized wire so it won't rust. To drain the wetland, one simply moves the vertical pipe so that it's parallel to the ground. The rubber gaskets in the 90-degree fitting allow you to rotate the structure without leaking. To close the water control structure, you simply rotate the pipe in the upright position and then secure it to the post with a galvanized wire. Beaver have never blocked this type of water control structure, and no one has ever vandalized one, even though they've been installed on National Forest System land that's open to the public. Other advantages are that you can adjust water levels in the wetland and not get your feet wet, and the gaskets won't leak or tear or have to be replaced. The rubber gasketed drain pipe combined with gasketed 90-degree elbow that's placed on the backside of the dam is the most reliable and the cheapest water control structure I've found in my 47 years of building wetlands and ponds. The red arrow points to the outside toe slope of constructed dam. The stream is emerging like it's a spring under the dam. The flow of water is not from the spillway. This stream shows that water is flowing under the dam, explaining why the pond only holds water after infrequent and heavy rains. The mud area and water you see in this photo is within sight of the backside of the dam for a pond that contains very little water. The saturated soil indicates that water is flowing from the pond basin and under the dam. Finding crayfish chimneys in the dam or in the basin of the dry pond indicates that water is entering the crayfish burrows and flowing under the dam via a permeable layer of sand or gravel. Many wetlands and ponds fail to hold water because buried drainage structures were not removed or blocked during construction. Expect to find buried drainage structures in every wetland restoration project you complete. It's of critical importance that you dig a core trench and build a groundwater dam around the lower 2/3 perimeter of each wetland you build, this being done to disable buried drainage structures and to block subsurface permeable layers of soil. This wetland is dry because the texture of soil in the dam and the basin is too low in clay to hold water. Wetlands and ponds that are not holding water as planned can be repaired by using the techniques described in this video series, including the groundwater dam technique, compacted clay liner technique, or the aquatic safe liner technique. It's very possible to build a wetland that will last for many years. This pond was built by hand over 2,000 years ago. It's located at Fort Ancient Earthworks and Nature Preserve near Oregonia, Ohio. Here's another one of the 114 ponds that were built by hand at the Fort Ancient Earthworks and Nature Preserve over 2,000 years ago. These ponds were built by excavating a basin by hand and then compacting the clay texture soil in layers. These wetlands have lasted over 2,000 years because they were constructed without dams, without pipes, or without water control structures, all that require maintenance. You don't have to build a dam when restoring a wetland or a pond. You're looking at a vernal pond we built 6 years ago on Ball State University's Cooper Farm in Indiana. The wetland was constructed by workshop participants in less than 1 day. More importantly, the wetland was built without a dam. Here's the spillway for the wetland we built at Ball State University without a dam. Water is flowing in a sheet-like pattern over undisturbed ground and has naturally formed a wet meadow wetland that does not require maintenance. You're looking at a vernal pond wetland we built on the Danube National Forest in Kentucky over 30 years ago in less than 1 day using a dozer. The wetland was built without a dam and has never required maintenance. Here's one of hundreds of vernal ponds we've restored on the Yakinuki First Nation Lower Kootenai Band Reserve near the town of Creston, British Columbia. None have involved the construction of dams, pipes, or water control structures. It's possible to build dams that will last for years, like the dam we built for this wetland over 25 years ago. Remember that it's important to inspect the dam, the spillway, and the water control structure several times each year and take immediate action to complete repairs. We built this wetland at Harbison State Forest in Columbia, South Carolina during a wetland workshop 21 years ago. The dam is only 18 inches high and it has a wide top with gradual 5% slopes. The spillway is also wide and carries overflow in a sheet-like pattern down a gradual slope. The dam and the spillway have never been maintained. My wife and I built this emergent wetland on our farm 28 years ago. The dozer operator shaped a 2-foot-high dam that has a 12-foot wide top with gradual slopes and a drop pipe water control structure along with a wide spillway. For maintenance, I've mowed the dam twice a year since it was built. There have been hundreds of thousands of ponds and wetlands that have been built across North America, and most every one of these has been built using a dam. Now, these dams should be inspected regular, and the maintenance should be completed as needed so that these ponds and these wetlands can last forever. Well, I'm Tom Beebekauser with Wetland Restoration and Training. If you like this video, please let us know, and please hit the subscribe button so you won't miss any future episodes, and I wish you every success in restoring and building wetlands and ponds. Thank you.